Namaskar. In the previous class, we had seen the criteria for exactness of an ordinary differential equation. In today's session, we shall see the methods of solution of the exact ordinary differential equation. So let us start the video. Now suppose an ordinary differential equation of first order and first degree m dx plus n dy equal to 0 is given, and you are told to find out the solution of this ordinary differential equation. Now, the very first step will be to test the exactness. What was the testing of exactness? That is del m del y equal to del n del x. It is happening or not. So you have to first test whether del m del y is becoming equal to del n del x or not. If it is equal, then we'll proceed to the next step. So if this is equal, then the given ODE is exact. Now if the given ODE is exact, you can find out a function phi such that m dx plus n dy equal to d of phi, because this was the definition of exactness. So first what we are doing, we are testing the exactness. When we are sure that the given ODE is exact, then we are applying the definition of exact ODE, that is m dx plus n dy equal to d of some function. Now if m dx plus n dy equal to d phi, then in the original equation, in equation 1, we can write d of phi equal to 0, because m dx plus n dy was equal to 0. Now if it is exact, then m dx plus n dy equal to d phi. So you can replace this one with d phi, that is d phi equal to 0. Now what is the next step? You just integrate this one. If you integrate d phi, what you will get? You will get phi equal to some arbitrary constant. So this is the solution. So the first step is you have to test whether the given ODE is exact or not. Then if the ODE is exact, you will have to write that m dx plus n dy equal to some function, the total differential of some function d of phi, and ultimately d of phi will be becoming equal to 0, because the original equation m dx plus n dy was equal to 0. So d of phi will become equal to 0, and integrating this one, you will get phi equal to c. That is the solution of ordinary differential equation, which is exact. So if the equation is exact, the solution is phi equal to c. What is phi? Phi is that function whose total differential was m dx plus n dy equal to 0. So ultimately you have to find out the function phi. If you can find out the function phi equal to c, that is the solution. There are three ways to find out the function y. I'll explain you the three different ways. The first one is a very methodical one. We'll see the methodical way of how to find out the solution by finding out phi, and the next two methods of solutions are shortcut methods, that is unexplainable, but the first method we can explain it. But for examinations, since you have time constraints, it is advisable that you can use the next two methods, because those two methods are you can do it in a very short amount of time and very shortcut methods. But let us first start with the very methodical way of how to find out the solution, because that is the only way in which you can understand the procedure of finding the solution of ordinary differential equation, which is exact. So let us see. Let us start with this example. Y dx plus x plus cos y dy equal to 0. Suppose this problem is given and you are told to find out the solution of this problem. The very first step will be to write down what is m and n. Here m is y, the function that is with dx, and n is the function that is with dy, that is x plus cos y. So m is y, n is x plus cos y. Then the next step is to test whether the given ODE is exact or not. What is the testing procedure? del m del y is becoming equal to del n del x or not. So you have to find out the expressions of del m del y and del n del x. What is del m del y? Differentiate this one with respect to y, that is 1. What is del n del x? Differentiating this one with respect to x, so that is 1 plus derivative of cos y with respect to x. Now derivative of cos y with respect to x, that will be 0, because when you are doing partial derivative with respect to x, you have to consider y to be constant. So cos y, that derivative will become equal to 0, plus 1, that is 1. So these two are now becoming equal. Therefore del m del y equal to del n del x. Hence the given ODE is exact. So this is the first step that you have to write. You have to test whether the given ODE is exact or not. Now there is a word of caution over here. If you fail to do this test, that means suppose a problem is given, and since you know the syllabus, you assume that okay, this problem is given, the given ODE will be exact, and you solve the problem correctly. Even though you solve the problem correctly, since you have missed this step, some marks will be deducted, because this step is the very initial step that carries some step marks which you have to show in the problem. Okay, so this is the step which shows that the given ODE is exact. Now if it is established that the given ODE is exact, then you can find a function phi, which is a function of x and y, such that we can get a phi which is a function of x and y such that d of phi will be equal to m dx plus n dy. That was the definition of exactness. Now by going to the definition of total differential, what you have, therefore what was the definition of d phi? Del phi del x dx plus del phi del y dy, that is equal to m dx plus n dy. Now see, from here, by comparing both the sides, what you have with dx, over here you have del phi del x, and over here with dx you have m. So comparing both sides, you have del phi del x equal to m, which implies del phi equal to m del x, which implies del phi equal to, now what is m? M is y, so del phi equal to y del x. Now if you integrate both the sides, what you have integrating both sides? Now see, our motive is to find out the function phi. If you can find out the function phi, then the solution is phi equal to c. Simply phi equal to c, that is the solution, where c is an arbitrary constant. Now integrating both sides, what you get? We get phi equal to, now see, it is a partial integration with respect to x, so you have to think y to be constant. So simply this is y integration del x, that is yx integration of only del x, that is x, plus there will be an arbitrary constant. Now over here, while integrating with respect to x, partial integrating with respect to x, you have thought y to be constant. So the arbitrary constant over here also will be some function of y. This you have to keep in mind. Please do not put plus C or plus M any other arbitrary constant, because over here you have kept y to be constant, so the arbitrary constant also will be some function of y. So you have got phi equal to yx plus some function of y. Now see, if you can find out what is fy, then you will get what is phi, and ultimately phi equal to c is the solution. So now our motive is to find out what is fy. Let us see. Now see, we have used this comparison. Now using this comparison is also necessary. What do you have? Del phi del y equal to n. Now del phi del y equal to n. Now from here, what you get? See, you have got the expression for phi. So over here, with respect to y, if you differentiate, what you get? X plus f dash y del phi del y. So differentiate this line with respect to x. Del phi del y equal to, with respect to x means you will get only y over here, y plus f dash, sorry, with respect to y you are differentiating. Since with respect to y you are differentiating, so del phi del y equal to x plus f dash y. That is equal to n. What is n? X plus cos y. X plus cos y. Now x gets cancelled out. You have f dash y equal to cos y. Now f dash y means actually it is the derivative of f with respect to y. So you can write f dash y as df dy equal to cos y, or df equal to cos y dy. Now integrating both sides, what you get? F equal to integration of cos y dy, that is sin y plus c. So you have got the expression of f. Now our work is to simply put the expression of f over here. So we previously had got phi equal to yx plus fy, and now after some calculations we got the expression of fy, that is sin y plus c. Now we have to simply put the expression of fy over here. So we are getting phi equal to yx plus sin y plus c. And what was the solution? The solution was phi equal to some arbitrary constant. Since we have considered c over here, phi equal to suppose c1. Therefore yx plus sin y plus c equal to c1. Now you can combine c and c1 together and write equal to some capital C. So this is the solution. So let us summarize what we had done. Given the problem, the very first step was to find out whether the given problem or the given ODE is exact or not. How did we find out that? We used the criteria for exactness, del m del y equal to del n del x or not. So that is the very first step. Do not miss that step. That step carries some step marks. After that, when we are confirmed that the given ODE is exact, then you have to write the expression m dx plus n dy equal to d of some function, say phi. Then our motive is to find out phi. If we can get phi by any means, the solution will be phi equal to some arbitrary constant, phi equal to c. So that is the way in which we had found the solution. Now after this, using the same problem, I will show you two more different methods of finding out the same solution. Now these two different methods will be some shortcut methods. There will be no analytical explanations over there. There will be some shortcut tricks which I'll show you, by which using a very short amount of time you can solve these problems. Now let us move on to the second procedure. Same problem. How will we tackle it? Now the first step is same, that is you have to test whether the given ODE is exact or not. So after testing, del m del y equal to del n del x, we'll proceed to the next step. The next step will be different from the previous procedure. What is m over here? Y, and n is x plus cos y. Now I'm telling you once again, testing for exactness is mandatory. Do not forget to use that step. Now after this, simply find out m dx. What is and n dy? What is m dx? Integration of y dx. Now integrating y with respect to x, that means y will be treated as constant, so it will be y integration of dx, that is yx. Next, integration of n dy, that is integration of x plus cos y dy, that is equal to integration of x dy plus integration of cos y dy, which is equal to, again, integrating x with respect to y, that means x will be treated as constant. Ultimately this will be xy plus integration of cos y, that is sin y. So integration of m dx, you have got yx, that is equal to xy. Integration of n dy, you have got xy plus sin y. Now the solution is, you have to simply accumulate these two solutions, that is integration of m dx plus integration of n dy. But you have to keep in mind, if there are any common terms in these two, you have to consider that term once only. So see over here in these two, the common term is xy, because you have xy over here also, over here also. So you have to consider xy only once. That is, if you add up these two, you get xy. For integration m dx, you have got xy, plus for integration of n dy, you have got xy plus sin y. Since xy is already over here, no need of considering xy twice. So plus you have only sin y equal to c. That is the solution. You can just rewind the video and see the solution in which we had used that analytical method. Over here it is same. So see, in a very short span of time, by using this trick, a shortcut trick, you have reached the solution, which is exactly same as the solution which we had got using that analytical method. Now there is another way also, shortcut way also, in which you can find out the solution. That is, you simply integrate m with respect to x and then integrate n with respect to y, but omit the terms containing x. So you have to omit the terms over here which contains x, and then you have to write equal to c. This will be the solution. So what it is, see, integration of m means y dx plus integration of n dy, but you have to omit the terms containing x. So you have to omit this term because this term contains x. So only cos y dy equal to c is the solution. So integration of y dx, that is yx plus sin y equal to c. See, same solution. So this is another shortcut way. Now there is an alternative also over here. What is the alternative? Now suppose you put all the terms of n over here, that is x plus cos y, then you have to omit the terms which contains y over here. So just the opposite one. Since in this process you are considering all the terms of n, and for n you are omitting the terms which contains x. Alternatively, if you use all the terms of n, you have to omit the terms of y over here. See, the same solution will come, because if you keep the term of x over here, it will be integration of x plus cos y dy, and you have to omit the term of y over here. Since you have only one term of y over here, so you have to omit this one and you will get the same solution. So these are the three methods, or rather procedures, by which you can find out the solution of exact ODEs. The first method, that is the best one, because in that method you exactly know what you're doing and it is a very methodical one. But the next two methods are shortcuts that do not actually speak of what the actual procedure is, but it is useful for examinations because that will save your time. Now before ending today's class, let us see another example of solving the exact ODE. Now this problem is given: e to the power x sin y plus e to the power minus y dx plus e to the power x cos y minus x e to the power minus y dy equal to 0. You have to find out the solution. Now first step is what? First step is to write out what is m and n. M over here is e to the power x sin y plus e to the power minus y, and what is n? N is e to the power x cos y minus x e to the power minus y. Then the testing phase, that is you have to test whether the given ODE is exact or not. So what is the testing criteria? Del m del y and del n del x, that both two expressions, these two expressions you have to find out. Del m del y, that is differentiating this line with respect to y. So with respect to y you are differentiating, that means you are assuming x to be constant, so it will be e to the power x cos y. With respect to y, that is minus e to the power minus y. Now what is del n del x? Differentiating this one with respect to x, keeping y to be constant, so it will be e to the power x cos y with respect to x, that is minus e to the power minus y. See, these two are equal. Since these two are equal, so the given ODE is exact. Now let us apply the shortcut procedure to find out the solution. So therefore the solution is integration of m with respect to x. So integration of m means e to the power x sin y plus e to the power minus y with respect to x plus integration of n with respect to y, omitting the terms which contains x. Okay. Now see, in n you have to omit the terms which contains x. N contains two terms, e to the power x cos y and x e to the power minus y. In both the terms you have x. So if you have to omit the terms containing x, you have to omit both the terms. Now if you omit both the terms, only 0 remains, 0 dy equal to c. That is the solution. Okay. So integrate this one, or now this is with respect to x, that means you have to consider y to be constant, so it will be e to the power x sin y plus x e to the power minus y plus 0 equal to c. So this is the solution. So over here we have used the shortcut method to find out the solution. The method was you have to integrate the m part with respect to x and then the n part with respect to y, omitting the terms which contains x. Over here, since all the terms contained x, we have omitted all the terms of n. You have to do equal to c, that is the solution. So my dear friends, in today's video, we have seen different methods of solution of exact ODE of first order and first degree. Now the first method was a very analytical one in which it was very much methodical and the procedure itself told what you're doing and what you're not doing. But the next two methods were shortcut methods that is used to save time in examinations. My advice is to use the next two methods for your examination purpose, but do not forget to understand or learn the first method, because that is the only method which will actually teach you how to solve an exact ODE. If you have liked today's video, then do share this video with your friends, follow my page and subscribe to my channel. Till then, goodbye.